It can produce highly advanced international rescue shovels. Can you believe it? A factory producing rescue shovels is equipped with highly automated welding equipment. Its numerous features make it incredibly mysterious and little known. Today, let's explore it in depth. What secrets lie behind the so-called King of India wooden handle and metal shovels? To create such a shovel, the most mysterious material is none other than the metal steel plate shown on screen. This is a type of hard carbon steel infused with carbon elements. Its main feature is its strength and resistance to deformation. It can meet the demands of any rescue scenario. This is the most practical experience gained locally after multiple earthquakes. Once the steel plate is prepared, the next step is to press and shape its fixed points and appearance. From the footage above, you can see that this process belongs to an automated assembly line operation. This method helps reduce inconsistencies in product quality. In the blink of an eye, a shovel head is born. As for how hard the steel plate is, the most crucial process is heat treatment. And shovels are no exception. Workers first evenly arrange the shovels in a furnace. Once the entire surface turns red hot, they remove it quickly, and then quench it in cold water. To help everyone understand just how hard this steel is, we'll conduct a small experiment. The worker places a cloth on the surface, and strikes it twice with a hammer. The shovel shatters into pieces, scattering everywhere. This demonstrates that the shovel is exceptionally hard. To help everyone better understand the principle behind this, let's discuss why harder steel tends to be more brittle. When large amounts of carbon are added to the metal, its internal structure shrinks and becomes unevenly distributed. Under external force, it risks fracturing. Only tempered steel can reduce this risk. The internal tension created during tempering improves both its toughness and hardness. Otherwise, a brittle shovel like this would hardly be used for rescue missions. As the machine slowly descends, the process enters the acid pickling stage. Pickling is a surface treatment process for metals. It removes the oxide layer and rust using a chemical solution. To enhance the texture of the shovel, workers polish the surface to a mirror-like finish. This gives the product high brand recognition in later stages. The shovel blade doesn't require much processing. It will later be spray-painted and colored. Now we move on to the next procedure. Workers first cut wood blocks into uniform sizes and then sand them into their overall shape. As the machine support moves forward slowly, cylindrical wooden blocks emerge from the other end. These wooden blocks form the handles at the center of the shovels. To ensure a secure fit, workers carve out both ends. With this piece of wood, the handle is firmly attached, preventing it from coming loose. As shovel handles, the choice of wood is also not simple. Jujube wood or elm wood are the main materials used. These types of wood have a high density characteristic. Moreover, it is heavy and wear resistant. Most importantly, it doesn't need reforging. After all, using a shovel requires forceful digging. If soft wood is used, there is a high risk of breaking. In no time, both ends of the wood are polished to completion. From its appearance, the surface is exceptionally smooth. This can be considered a quality piece of wood. Additionally, one end of the stick must be cut. This prevents splitting downward. A hole must also be drilled at the base. Later, a screw will be added in this spot for reinforcement. To prevent hand injuries during use, the center must also be polished smooth. At this stage, a screw can be secured to one side. Although only one screw and nut are installed, after treatment, the side will be extremely tight. There's no need to worry about it coming loose. Careful viewers might guess what this step involves. Workers heat the wood with hot water to soften it, making shaping easier. Here's a close-up of the process. You can clearly see how the handle changes its shape. Grouped in tens, they are slowly transported forward. This step is slow and time-consuming. After several minutes, it reaches the worker. The mold is then removed, and the previous wooden block is installed. After the mold is removed, there's no rebound effect. The handle is mainly secured with screws. One large screw is added at both the top and bottom. This is the primary method of securing the handle. Let's have an experienced worker demonstrate. In the worker's hands, the wooden stick becomes even smoother. Every part is polished evenly. But it makes one wonder if it might cause splinters. The handle also requires external force to secure it, as it's difficult to firmly attach the two parts otherwise. For those familiar with using shovels, the sturdiness of a shovel mainly depends on the handle. If pine or poplar wood is used for the handle, it's likely to break after only a short period. In most cases, elm is used for handles in China. In northern regions, elm is even nicknamed elm knots. symbolizing stubbornness. This shows that there's no need to worry about the durability in India either. Next, the shovels are painted. The main purpose of this layer of paint is to enhance appearance. After all, frequently used shovels will eventually have all their paint worn off. With the wooden-handled shovels completed, we'll now take 2 minutes to explore the secrets of metal-handled shovels. The identical metal tubes in the footage are the raw materials for handles. Unlike wood, metal tubes must withstand significant gripping force. Therefore, polyurethane is added inside the tubes to prevent potential collapse issues. If solid metal tubes were used instead, there would be no such concern at all. Next, we begin assembling the steel tube handles. The raw material is still hard carbon steel. The worker first aligns each part evenly. Then they press them together from both sides to secure them. To avoid uneven welding results, an automated welding machine is used for reinforcement. The main purpose of the robotic arm is to replace the bowstring. As for the welding process, it appears to be extremely fast. Both sides are welded simultaneously, forming one handle in less than 10 seconds. If it relied solely on manual labor, it's hard to imagine how long it would take to weld a single handle. This shows just how evident the benefits of automation are. Now comes the most exciting part. Everyone, open your eyes and watch closely. This process uses multiple synchronized welds. In other words, welding completes one set from start to finish, then moves on to batch weld the next set. Doesn't this process look incredibly efficient? Moments later, workers start installing the metal pipe into the shovel. Each pipe is tapped into place one by one. This section is where the steel pipe and shovel blade connect, ensuring a tighter and more secure fit. Otherwise, relying solely on welding could easily lead to breakage. It's clear that a lot of thought has gone into this design. At this point, a sturdy and durable shovel is finally completed. To meet standards, every batch of shovels undergoes manual inspection. The inspection process looks rather rough. After fixing both ends, workers place a heavy object on one end, then gradually pull it downward. At this point, it's evident that both the steel pipe and the shovel blade have impressive resilience. Moreover, there are no significant shape changes, remaining just as before. Let's move on to the final testing phase. This concludes the entire shovel manufacturing process. What do you think is better, a triangular-headed shovel or a straight-handled shovel?